And next up, we're going to have the Phasecraft team join me on screen here, and we're going to be talking about Phasecraft and everything that it's doing in quantum computing. So hopefully we'll have the founders, Toby and Ashley, joining me on screen shortly, and we can talk about that. Hey, there we go. Ashley, great to see you. How are you doing?
Hi, Dave. I'm fine, thank you. Great to be here.
Excellent, good stuff. And Toby here too. Toby, brilliant.
Hi, Dave.
And I see you've worn your Phasecraft stash.
Absolutely, yeah.
I apologise.
Policy. I have to sit here every day in it.
I'm not wearing the t-shirt you provided me. I feel bad now, but great to see you fully branded. So Phasecraft is a quantum computing software company. There's a huge amount of hype and interest in quantum computing right now. It'd be great to get right at the start of this just your view on where quantum is at. What's the state of the quantum computing industry right now?
Yeah, I can take that first, and then Ashley can chip in. So we've got a mixture of, there's a huge amount of hype, as you said, and the hype is not completely unfounded. There have been some major milestones that have been hit for the first time in history within the last couple of years, 2-3 years. The famous Google so-called Supremacy Experiment is it's a milestone. It's something the field had to pass to show that quantum computing was coming of age. But there's also a huge way to go as well, in that we have hardware that for the first time in history can compute in a way, demonstrably compute things that can't be done on normal computers, even on the world's biggest classical supercomputers, really at the limits. But at the same time, no one's demonstrated a computation yet that's useful for some practical task on these machines. They've implemented things that are very nice pieces of science demonstration. So the huge challenge where quantum computing is that we're finally reach the stage where quantum computers are no longer toys that you just play with in your laboratory. They're things that you can actually run computations on that go beyond anything you can do on the world's best supercomputers. The big challenge now, and the challenge Phasecraft is focused on, is turning that really early stage quantum hardware into something that's practically useful for real world tasks. And that's a huge challenge, but also huge potential. So the hype is justified, but it's also, one shouldn't underestimate the challenges involved in doing that.
And Ashley, where does Phasecraft fit into sort of solving those challenges?
Right, so we're a quantum software company. So we, roughly speaking, design software for these quantum computers. But this word software is really a very broad one, and it encompasses everything from designing and optimizing the quantum algorithms through to running them on real hardware, coding them up for these real quantum computers that now exist. And really, one of the key challenges to get to this point of quantum advantage for a real world problem of great practical import is making these algorithms as fast as we possibly can, because the sort of quantum computers we have now, as Toby mentioned, are really incredibly limited compared with how they will be in the future. They're still more powerful than the world's best supercomputers for some problems, but to get the most out of them really needs a lot of hard work and a lot of careful thought to try and make the algorithms as good as possible. And that's really Phasecraft's main goal. Our main challenge is to get the most out of the hardware and get to this point of quantum advantage.
What is it about Phasecraft that makes it the right company, the best placed company to be able to solve that challenge?
So I would say that there's a couple of things. I mean, firstly, the quality of the team. I mean, I think we really do have a fantastic team that we've built up. I mean, the founders all come from a background in academia, working on quantum computing for the best part of 20 years for each of us. But beyond that, we've managed to hire some outstanding earlier career staff. And I think that's very important. But also, I would say our focus is really critical for this, in that we are really trying to be laser focused on this problem of getting to these important applications of quantum computers. And there are lots of other people who are doing slightly different things, like working on operating systems, maybe, or compilers, or even nice websites. And these are all important things to do, but they won't get us to this critical stage of quantum advantage. So that's really what we're trying to aim for.
Great. So you've got right at the sort of coalface of solving the hardest technical challenges in quantum. And Ian was saying earlier how he sort of diligenced Phasecraft when he was sort of getting involved. Me too, just sort of speaking to the quantum world. And it's clear that the founding team at Phasecraft just have an incredible academic track record and pedigree. So you really are the right people to be taking on this challenge.
I think one thing worth chipping in there, Dave, though, is that whilst Ashley and I are great, we also, because we're really attacking the really difficult, ambitious challenge that very, very few other people are taking on, that also attracts really great people to the team, because the smartest people want to attack the big challenges, the ones that are really going to make a difference, not just kind of chip away at developed platforms for someone else to do the big progress on top of. And that's why, although Ashley and I are great, our team is is better than we are, and I think that's a key strength of Phasecraft.
And like you say, the team is absolutely critical and a key strength for a business like Phasecraft, where a lot of the value is concentrated in the brilliance of the team. How are you sort of developing a company culture and a team that is fit to solve those challenges and continues to grow and maintain that excellence?
So I'd say at the moment, this is actually a really critical question in the field of quantum computing, because there is this incredible talent squeeze where there are just not enough people who are able to do the job of designing quantum software or indeed quantum hardware. So motivating these people to come and work for us and to perform at their utmost is incredibly important. And I think one thing we really try to achieve is sort of foster this kind of supportive culture where everyone is sort of trying to work together, like really as a team rather than individuals, to chip away, as Toby said, at these incredibly challenging problems. And I think many of the people that we hire are people who might otherwise be going to work in academia, maybe as a postdoc or a faculty member somewhere. And I think a thing which is quite different in working in a startup company is this fact that you are all focused together on this one goal, and you're not each working on your separate research project, which may be very valuable, but is a sort of individual thing. You're all trying to sort of contribute to this broader picture. And I think this is a very important part of what we do.
Yeah, and whilst, a lot of the people we're hiring are people who have got very strong academic backgrounds as well, and they're always going to be, at this stage of quantum computing when it's so R&D focused, even in industry, they're always like, where's the most interesting place to work? And I think what we found is that as people are still, the best scientists are still justifiably skeptical about quantum, in that there's a lot of hype. They're not actually seeing a lot of the stuff that's going on behind the scenes is not necessarily being published fully immediately. And when they come and work for us, it's a very different process working in a company than academia. The scientific problems are just as challenging and interesting. What's different is what Ashley says, is it's much more of a team effort than produce another paper and then you leave it aside. You're really working together towards some really clear goal. We don't necessarily know the best path to get there. There's lots of different ways to explore, but it's all kind of focused on a very clear end goal and something that you can build long term, not just you do one project and then you sweep it aside and do the next one. And that's something that we found our team is really motivated by.
Excellent. And what are the kind of near-term goals that you're aiming for? So what can we expect to hear from Phasecraft over the next year? What will be the sort of exciting milestones that you're trying to get your team to crack?
We have a whole range, so I'll take a few and Ashley can fill in. So on the one hand, we're still working. We haven't finished. We haven't run out of steam of optimizing algorithms and inventing new algorithms for quantum computers. And this is really important because, the hardware is incrementally improving, but at a relatively steady rate. However, if you can make algorithmic improvements, like in the very early days of classical computing, some of our IP has shaved 5 orders of magnitude off some of the best algorithms from a couple of years ago by Google. That translates into a decade earlier that you'll be able to run the algorithm on quantum computing, even if you believe in an exponential growth of the quantum computing hardware. So we're certainly not done with that. We're still squeezing orders of magnitude out of everything we do. But another key important thing that I can hand over to Ashley to talk about is actually now implementing this on real quantum hardware. Do you want to talk about that, Ashley?
Yeah, sure. So we're building up some partnerships with some of the world's leading quantum hardware manufacturers. So we've announced partnerships with Google, Rigetti, and recently IBM, where we're coding up the algorithms and the software that we develop for their world-leading hardware, and in many cases demonstrating things that have never been shown before. Like we're taking the theoretical advances that Toby mentioned and showing that they do work in the real world on real quantum computing hardware. And in some cases, these things are sort of small-scale demonstrations, but this is sort of working up to the point where they are going to be outperforming our best classical computers for things which are genuinely relevant. So that's a sort of really critical direction for us in the next couple of years, let's say, is getting to this point with sort of real code on real hardware, solving real problems.
And it's important to emphasize, now we're not, all of the algorithms we're developing are really focused on concrete applications, not just sort of algorithm research. So we're very much focused on quantum simulation, in particular in the material science space. And a lot of our hires now are not people who, not all from quantum computing backgrounds, but a lot of material scientists and condensed matter physicists, working also in partnership with some of the UK's big material science companies, really with their R&D teams, to make sure that everything we do is actually targeting running a real, not some demonstration of some scientific problem, but an actual showing that you can actually run real applications on this hardware.
Amazing, very cool, very cool. You were touching earlier on the differences between working in a startup environment and an academic environment. You've both sort of made an incredibly successful transition from academia to sort of academic entrepreneurs. There'll be lots of people who are attending the showcase today who are sort of thinking about starting that journey. It'd be great to sort of get your wisdom on and experience and some advice for those guys.
So yeah, maybe I'll go first and Toby can chip in. So I guess I would say, firstly, to people who are thinking about making this leap, that it is a very exciting move to make. And for some people, depending on what your research area is, it can also be a very natural move. I mean, a lot of people in academia have sort of longer term, more sort of blue sky things they work on, and nearer term, more applied things they work on. So it's very natural to think about, okay, maybe that near term stuff, we can really make it into a company and do something sort of, do something really real world with it. So I think it is a very exciting and natural move for a lot of people. And I think I'd say as well that as an academic, for many people, there are a lot of the same skills that you use in academia, which are actually very relevant to setting up a startup, like whether it's building a team, whether it's writing grants, whether it's actually doing the research itself. I mean, these are all things which I think are important in a deep tech startup like ours. So I think for many people, it's a natural move to make, and I think it's a very exciting one.
I'd also say that back 20 years ago, when I was a PhD student, there was a view that leaving academia was kind of failure. And what I really heartened by now, especially like in UCL with things like the UCL Tech Fund, is that now PhD students are not viewing that as a bad option. They're really fluidly moving between our industry research, scientific research, and also many students thinking of starting their own companies. And that kind of entrepreneurial spirit wasn't there 20 years ago in the same way. And I think that's a really positive development, because definitely within Phasecraft, the research we're doing is every bit as exciting and interesting as we do in academia. And yeah, it's just great to see that change in the culture.
Yeah, so and do you think the ecosystem has gone far enough, or is there further support more that you'd like to see from the kind of academic entrepreneurial ecosystem?
I mean, there's always more you'd like to see, as Ashley emphasized. I mean, one of our big bottlenecks for the whole quantum industry is the supply of talent. There are not enough people coming out who are with PhDs in the right area or with degrees in the right area who have the skill sets to do that. It's a real shortage of supply. And that's something that really is best supplied by academia or partnerships between industry and academia. So we're very fortunate to have a lot of these because we have close connections to two universities, both UCL and Bristol, and the kind of academic track record. But there's always more. I mean, we're very keen on supporting still on the academic side, training up the next generations of these more entrepreneurial academics, like you said.
Yeah, both universities have this PhD
CDP.
track.
Yeah, that's right.
It's helping us out, which is again, seems to be very useful for Phasecraft.
That's right. Yeah.
Excellent.
Yeah, I mean, CDTs, the doctoral training centers are indeed, both of them have structures in place for industry academic partnerships, which give the students the opportunity to do an internship, or what looks like, as part of the program, or do a PhD sponsored by industry. And so we support a number of PhD students through that scheme with both universities from Phasecraft.
And so, yeah, it's been incredibly valuable. I guess I would just like to see it go even further down this line, let's say, and I would like to see really a lot of the top graduates from the top universities in the UK, really thinking that this is one of the most exciting things they can do, rather than necessarily going to some other careers. We want to grab some of these people for deep tech.
Well, I think the ongoing success of Phasecraft is only going to help with that. Only going to be a big part of helping people see that as an exciting part of the journey for a PhD student. Guys, thank you so much for coming along to the showcase today. It's really exciting to see what you've been doing. I mean, talking about some of the improvements you've made, like many orders of magnitude, decades worth of improvement in such a short space of time. It's been an incredible journey to be with you on, and I'm so excited about the next phases. So thank you for coming along and sharing some of that with the audience today. I'm sure they massively appreciate it.
Thanks a lot, Dave, and to UCL Tech Fund for all your support along that journey.
Yeah, well, you're welcome. It's been wonderful.